Good morning, class, and welcome back. I hope you all had a good weekend. I need everyone to take out the article they were supposed to read for class, and I need a volunteer to read their summary. Yes, Chris.
The article entitled Game-Changing Gene Therapy Nullifies Patient Sickle Cell Disease describes sickle cell disease in a study reported in the New England Journal of Medicine. Individuals with sickle cell disease carry a mutation in genes for hemoglobin, which makes up a person's blood. That mutation makes a blood cell shape and functions abnormal. Symptoms of the disease are anemia, stunted growth, strokes, and increased susceptibility to illness. In this study, an anti-sickling gene was inserted into a 14-year-old patient's stem cells using a modified virus. These cells then transformed into red blood cells that function properly and spread throughout the body. About a year after this treatment, the teenager was not suffering from any effects of the disease, and over half of his cells appeared normal.
Great, thank you. Today we're going to review what gene mutations are, what sickle cell disease is, and how it works. There are several types of gene mutations that change the function or meaning of genes. Does anyone remember the different types of gene mutations?
There are base substitutions, deletions, and insertions. Base substitutions are when one nucleotide is replaced with another. Insertions are when a nucleotide is inserted into a sequence and causes the reading frame of the mRNA to be altered. Deletions are when a nucleotide is deleted from the sequence, also causing the reading frame of the mRNA to be altered.
Very good. Can anyone tell me the effects of gene mutations?
I do. There are 4 effects that the mutations can have on the sequence. Silent means that it does not affect the gene product or phenotype. A missense causes one amino acid to be substituted for another. It may or may not be serious depending on whether or not it changed the amino acid sequence. Nonsense causes translation to stop early and almost always creates a non-functioning gene. A frame shift causes downstream codons to be misread, often caused by a deletion or insertion.
Excellent. Now let's look back at the article you all read for homework. The mutation that causes sickle cell disease is called a point mutation, where only one nucleotide is copied incorrectly in the gene for hemoglobin beta on chromosome 11. The base substitution causes a missense, where one amino acid is substituted for another. As you can see here, this is the normal DNA sequence for a red blood cell, and in the sickle cell mutation, the adenine is substituted for a thymine, which causes the difference in amino acid sequence, which leads to the difference in shape of the red blood cell. These sickled cells clump together and clog bloodstreams, causing circulation throughout the body to weaken. As you can see here, normal red blood cells flow freely throughout the bloodstream. And here in sickle cell, the abnormal shape causes them to clog the bloodstream.
Can I inherit sickle cell disease?
Yes, it is possible to inherit sickle cell disease. It is inherited in an autosomal recessive pattern, which means both copies of the gene have mutations. This means that a child must receive a sickle cell gene from both the mother and their father. If a person inherits only one sickle cell gene, then they are considered a carrier. If 2 carriers mate, then their offspring will have 1 in 4 chances of having sickle cell disease. Class is dismissed. Don't forget to read your textbook for tomorrow.